Net classes and notes can make your schematic more understandable. But, are they difficult to use? Let's find out. Jumping back to the schematic from the previous video, we can open the schematic setup menu and select Net Classes under Project. The top section shows our schematic is only using the default net class. To add a net class called Power, click the plus button and type Power into the name field. We will set the wire thickness to 18 mils and the color to red. Click OK to save the changes. How do we assign the VBus CNet to the Power Net class? Right-click on the label and select Assign Net Class. Select Power from the drop-down box on the right and then click OK to save the changes. Now all VBus C wires are colored red and have a thickness of 18 mils. This is the easiest method for nets with an assigned name and is perfect for schematics with only a few nets. Does this method work for implicit nets, like GND? No, but we can also assign net classes using patterns in the schematic editor. The bottom section shows we have 3 patterns, which are just the names of the nets we manually assigned. Click the plus button and type in GND, select the return net class, and click OK to save the changes. Now all the GND wires are colored black and have a thickness of 18 mils. This method is also useful if there are many nets and assigning them individually would take too much time. Lastly, let's create an analog net class with color blue. If we don't set the wire thickness, what will it be? This depends on the other net classes the net belongs to. For example, if the net was assigned to analog and power, then the wire thickness would be 18 mils. But, if the net is only assigned to analog, then the wire thickness will be 6 because that is the value used by the default net class. The default net class has lowest priority and ensures that all mandatory field values are set. Let's now move on to documenting our schematic to help others and our future self quickly understand the design. For example, why is resistor R2 set at 2.7 k ohms? What does signal VBus control do? Why are the CC1 and CC2 pins of the TCPP01M12 tied to ground? Where possible, I prefer to add custom fields to the symbol. In this schematic I used the use field to explain the purpose of the element and the note field to store a generic comment. For example, for resistor R2, the use field is limit VBus to 6 volts and the note field is set per STUM27-73, Rev 9, page 5, table 1. These two fields completely document the R2 resistor. If a symbol field note cannot be used, then I prefer a text box and a clear link to the schematic element the note applies to. For example, to document pins 1, 3, 10, 11, and 12 of the TCPP01M12, I've used footnote-style links to the text box. After reformatting, our schematic looks like this. It is tidy, aligned, has 0 crossing lines, and plenty of color to help identify different elements. Additionally, there is a lot of information contained in the notes to help anyone quickly understand the purpose of the circuit and the reasons it is the way it is. To summarize, net classes in KiCad are very useful and easy to implement. In this video we only use them to set graphical properties in the schematic. Later they will also be used to set PCB design rules. In the next video we will extend the circuit by adding more protection and debugging elements.